All right, unit 3.2, we're still dealing with transformations. We're still looking at rigid motions. It doesn't change the size or the shape. We're just doing reflections this time, right? 3.1 was transformations. That was slide to the left, slide to the right, slide up and down on the y-axis. This one is reflections, right? We're literally going to reflect something over the y-axis or over the x-axis, right? But it's still a rigid motion transformation. All right, so a reflection is a flip over a line called, strangely enough, the line of reflection. Line of reflection. So wherever we reflect it across, that's our line of reflection, and we're going to pick up the shape and we're literally going to flip it. Right? You can see right here, we took the shape and we flipped it over the y-axis. We flipped it. Pre-image, image. So that's what we're doing. We're reflecting it over something. Whatever we reflect it over is called the line of reflection. All right? Each point and its image are the same distance from the line of reflection, right? So if B is 1, 2, 3 from the y-axis, then B prime is 1, 2, 3 from the y-axis. It's the same exact distance from the line of reflection. All right? C is 1, C prime is 1. This can help you if you can remember that. It's the same exact distance from the line of reflection. A reflection is also an example of a rigid motion. Remember, I just said that because it doesn't change the size or the shape. Right? It preserves the original shape. Right? Common lines of reflection. So most of the time you're going to be reflecting over the x-axis or the y-axis. These are the most common. These are the most common. You're either going to reflect it over the y-axis or you're going to reflect it over the x-axis. Right? But not always. Sometimes you're going to reflect it over other horizontal or vertical lines. Right? So vertical lines will be in the form of y equals some number. It will tell you what line to reflect it over. Y equals something, and we'll look at that later. Or horizontal lines, we'll look at x equals something, right? It'll tell you what it wants you to reflect it over. We just have to do it. Right? And then we also have diagonal lines. Diagonal, you say, right? So what if the line of reflection is this line? Ooh, that's not even, let's try that again. What if it's over this line? If you're reflecting it over this line, this is a positive slope. So that is y equals x. Good old y equals x. Right? The definition of this line is y equals x. Right? And if it's diagonal in the other direction, now it's a negative slope. So it's going to be y equals negative x because it's a negative slope. Right? But these are all the different lines of reflection that a shape or figure can be reflected across. Right? So let's see what this looks like. Graph and label each figure and its image under reflection in the given line. Give the coordinates of the image. All right, so it's going to give us the pre-image. It's going to tell us what to reflect it over, and then we have to figure out the after, the image, and its actual coordinates, right? So let's ask ourselves, if we're reflecting over the x-axis, right? Let's ask ourselves what the rule is. Let's figure out the rule. We can figure this out, right? So remember that they're the same distance from the line of reflection. I just picked two random points, right? This point is 3, 2. This point is 3, -2. What changed? Between these coordinates and these coordinates, what changed? The 2 became negative. That's our rule. When you're going over the x-axis, right? You change the sign of the y value. Change the sign of the y value. That's our rule. If we're going across the x-axis, we change the sign of the y value. That means we can do that. We can literally just change all the signs of the y values. Right? So, this is -4, 2. This is my x and this is my y. So, if a is -4, 2, then a prime is going to be -4, -2. I changed the y value from +2 to -2. The x value stays the same because we're going over the x-axis. X value stays the same because we're going over the x-axis. The y value switches signs. If it was negative, it becomes positive. If it was positive, it becomes a negative. It changes its sign, right? B, 4, 7, so it's going to become 4, -7. B prime is going to be 4, -7. And C, which is 5, 1, C prime is going to be 5, -1. So all we did was change the sign of the y. Now let's graph it and see what that looks like. Let's see if it even makes sense. Let's see if it works. Our rule says it's going to work. Let's prove it. Right? So first we're going to plot the pre-image. A is -4, 2. I'm taking this off there. -4, 2 is A. B is 4, 7. And C is 5, 1. Is C. Right? It's a very sensitive board. All right, let's connect them so we can see what it looks like. It's not going to be perfect because I'm drawing it with my hand, right? You're going to use a ruler, and it makes a huge difference. Okay, let's draw our new image. A prime is -4, -2. Already you can tell it makes sense. They're the same distance from the line of reflection. This is 2 above, this is 2 below. Right? Then we have B, which is 4, -7. B prime. C prime is 5, -1. Let's connect it, see if they look the same. Right? So we literally reflected it over the x-axis. And all we had to do to reflect it over the x-axis is change the sign of the y value. Now let's do one over the y-axis. Let's see if the rule applies to if it's the same rule. But let's just check, right? Let's check. Let's make it big again so we can see it. All right, so this time we're going to reflect over the y-axis. Pick any 2 points. Make sure they are equidistant, the same distance from the line of reflection. The values here are -1, -1. And the values here, the coordinates are 1, -1. So this time what changed? What changed from here to here? The number itself didn't change. The only thing that changed was the sign in front of the x went away. So when we're crossing over, right, when we're crossing the y-axis, when we're reflecting over the y-axis, we're going to change the sign for x value this time. This time we're going to change it for the x value. We're reflecting over the y-axis. We're going to change the x value sign. Right? Now let's see if this works. Anytime you forget, you can do that little thing where you figure out if you're right and to remember the rule. You can derive or discover the rule just by picking 2 points that are the same distance from the line of reflection and checking. You can find your rule again and again and again. You don't have to memorize it. All right, so original 1, 2. That's P. Q is 2, 5. Q. R is 8, 3. And S is 7, 0. All right, let's connect them, see what it looks like. Okay. Now let's figure out our primes based on our rule. Our rule says if we're crossing over the y-axis, which we are, it told us we were, right, that you're going to change the sign for the x value. It was 1, 2, so now it's going to be negative 1, 2. I changed the 1 to negative 1. I changed the sign on the x value. 2, 5. So Q prime is going to be negative 2, 5. 8, 3. R prime is going to be negative 8, 3. All I'm doing is changing the sign on the x value. 7, 0 becomes negative 7, 0. That looks like that. All right, now let's plot the image and see if it looks like it reflected over the y-axis, which is what it was supposed to do. If it ends up down here, then we did something wrong. Right? But if it reflects over the y-axis, it should end up over here somewhere. Right? So let's see if we did it right. Negative 1, 2 is P prime. Q prime is negative 2, 5. Q prime. R prime, negative 8, 3. S prime, negative 7, 0. And let's connect them. It literally looks like we took this side of the paper and flipped it onto this side of the paper. That's a reflection. We flipped it on the y-axis. We reflected over the y-axis. All right, you do 3 and 4. We'll see how you did. And then the next step, reflecting on other or vertical or horizontal lines. So what if we don't reflect on the x-axis or the y-axis? Remember sometimes I told you it would be in the form x equals or y equals something? Right, so first we have to plot our points. Where is our line of reflection? That's what we have to ask ourselves. Right now it's telling us that our line of reflection is at x equals 4. Right, so x, which is this one, equals 4, 1, 2, 3, 4. That means that our line of reflection is right here. That is our line of reflection. Right? Because x equals 4. It's telling us this is our line of reflection. So let's plot our original. Triangle JKL with vertices J, 1, negative 1. 1, negative 1 is J. 2, 3 is K. And 3, negative 2 is L. Right? There are a couple of different ways you can do this. Sometimes it's easier to use the visual, right? Because we know that a reflection has to be equidistant from the line of reflection, you can just ask yourself, how far is K from the line of reflection? It's 2 spaces. That means I need to go 2 spaces the other direction for K prime. How far is J from the line of reflection? 1, 2, 3 spaces. So that means I need to go 1, 2, 3 spaces to get J prime. L is 1 space. So L prime is 1 space. And then when I connect them, it looks like I flipped it directly over the line of reflection. And if you do it this way, if you do it by looking at your equidistance, then all you have to do is figure out your points, and you can just fill the information in down here, right? J, if I wanted to get to J, 1, 2, 3, 4, 5, 6, 7 right, 1 down. So I went 7 right, 1 down to get to J prime. That's not right. Yeah, it is. All right. And then to get to K prime, start at the origin. I went 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3 up. So I went 6 to the right, which is positive 6, and I went 3 up, which is positive 3. All right, and L to L prime. All right, so 1, 2, 3, 4, 5 to the right, and 1, 2 down. 5 right, 2 down, not 1 down, 2 down. 5 right, 2 down. And now I have my coordinates for my image, for my primes, right? In many cases, this is the easiest way because you know it's going to fit on the graph, so you know it's going to be easy enough to count from your line of reflection. So if K is 2 spaces to the left of the line of reflection, then K prime should be 2 spaces to the right of the line of reflection, period. So as long as you can find the coordinates, you can do it this way. What if you can't find the coordinates, you say? There's another way. All right? Let's see if I can explain this in a way that makes sense and doesn't confuse the issue. All right. So, you have to ask yourself, what is the distance between your line of reflection and your original letter? Right? Between here and here, there are 3 spaces. Right? Between 4 and 1, there are 3 spaces. Make sense? And then we're going 4 more spaces, so we're going to add 4, which gives you 7. That's where we get the 7. Let me do that again, so you can see it again. All right, the distance between 4 and 2 is 2. 2 plus 4 is 6. Again, the distance between 4 and 3 is 1. 1 plus 4 is 5. Which way do you like better? Do you like reflecting the image and then finding the coordinates? Or do you like finding the coordinates and then plotting your image? You decide. Let's do another one. We'll do it both ways. The first time we did it by plotting the image and finding the coordinates. This time we'll do it backwards. All right, so we'll plot the original parallelogram. It's going to have 4 corners, C, D, E, F, four corners with vertices. C is -4, -4. So origin, 1, 2, 3, 4, 1, 2, 3, 4, and this is C. And then D is -2, 0, 1, 2. E is 6, 1. 1, 2, 3, 4, 5, 6, 1. E. And F is 4, -3. 1, 2, 3, 4, 1, 2, 3. F. Alright, let's take out all the extra stuff so we don't get distracted. Connect. Four corners. Alright, and where is our line of reflection? It's at y equals 2. Where is y equals 2? Y, 1, 2. Y equals 2 is right here. That means our line of reflection is right there. We're going to flip over it. Alright, so let's do it mathematically, and then we'll do it the other way. Alright, so because we're going over the y, as the line of reflection is a y value, we're going to be changing the y's. Does that make sense? Because this is why we're changing the y's. Because the line of reflection is here, we're changing the y values. Alright, so 2, the distance between 2 and -4, right? 2 minus 4. No, I don't want to write it that way. I'd rather you use a number line. Right? 0, 1, 2, 3, 4. We're getting the absolute value of something, and I don't know if you know the absolute value. I don't know if you know what the absolute value is, so I don't want to do it that way. Alright, so the distance between 2 and -4 is 1, 2, 3, 4, 5, 6 spaces. The distance is 6. 6 plus 2, right? The distance is 6. 6 plus 2 is 8. So it's going to be -4, 8 for C prime. I know, it's a little complicated, but that's okay. You can do the number line in your head after you've had some practice. Alright? So the distance between 2 and 0 is 2. 2 plus 2 is 4. So this becomes -2, 4 for D prime. The distance between 2 and 1 is 1. 1 plus 2 is 3. The distance is 1. 1 plus 2 is 3. So it's going to become 6, 3. And then the distance between 2 and -3, use the number line if it helps. 2 and -3 is 1, 2, 3, 4, 5. The distance is 5, and we add the 2, so now it's going to be 7. 4, 7. Some of them you can do in your head, some of them use the number line. Because it's asking for the distance between these two values. It's not about positive or negative. It's about distance. And the distance between you and something else is always going to be positive. Alright, so let's plot these and see what it looks like. See if it looks like we flipped it over. -4, 8 is C prime. -4, 1, 2, 3, 4, 5, 6, 7, 8 is C prime. D prime is -2, 4. D prime. I don't like how I wrote prime. E prime is 6, 3. 1, 2, 3. And look, it makes sense. If E and E prime are the same distance from the line of reflection, then it makes sense that they're each one away. E is one below the line of reflection, and E prime is one above the line of reflection. So you know you're doing something right. You know you're doing something right. All right, and then F prime is 4, 7. 4, 1, 2, 3, 4, 5, 6, 7. All right, so now I'm going to connect them, see if it looks like I reflected it over the line. Yeah, perfect. All right, let's see, reflecting in the lines, on the lines, y equals x and y equals negative x. These are our diagonal lines of reflection. All right, so let's do one of each so you can see what it looks like. These ones are interesting because remembering the rule is almost impossible. But if you remember that they're equal distance from the line of reflection, you can always find the rule. You can derive the rule from your knowledge, right? So y equals x looks like this, right? Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, all right? So it creates a line. It's not perfect. Don't judge my line. All right, I'm feeling you judging my line.